Hello and a warm welcome. This is Mr. T. Thank you for tuning in. I hope I find you well. This is a continuation to our video edition on sequences and series. And in this specific video, we're looking at the grade 12 aspect, that is the geometric series. I urge you, before you even watch this video, go back to the previous video on geometric sequences. You would notice that this is the second aspect. Like I said, we have dealt with the arithmetic series before. So this is just a continuation. So without any waste of time, we go straight into it. Determine the sum of the series 27 plus 9 plus 3 plus up to 10 terms. Notice that up to 10 terms represents your n. So n is 10. So we're going to state that our n is equals to 10. But more importantly, if it's not stated whether it's geometric or it's arithmetic, you need to investigate between your terms to see if there is a common difference or a common ratio. But I've given it away already. It's going to be geometric. So we're dealing with an R. So you state your values of A, which is equals to 27, your R, which is equal to 1 over 3, your N, which is equals to 10, then the S10, which is what we're looking for. We're looking for the sum of the first 10 terms. We are going to use the formula for the geometric series given by Sn is equals to A into 1 minus R to the power N over 1 minus R. Thereafter, we just substitute the values. We're going to have 27 into 1 minus a third to the power 10, all that over 1 minus a third. Simplifying that, we're going to have S10 being equal to 40,5. We move on. The second question is saying, determine the sum of 8 plus 4 plus 2 plus up to 1 over 32. Notice our Tn, the last term, is 1 over 32. So that 1 over 32 represents Tn. We state A is equals to 8. Our R is equals to half. Our N is unknown. Our Tn is 1 over 32. Our Sn is unknown as well. So we've got two unknowns, N and Sn. But to get N, we need to use the general formula for a geometric sequence, not series, geometric sequence, which is given by Tn is equals to A times R to the power N minus 1. Then we substitute our Tn, our A, and our R to get 1 over 32 is equals to 8 times half to the power N minus 1. The objective now is to solve for that exponential equation by making sure that both sides have the same base. Another person would have opted to use logs, which is too applicable and it works. But I'm going to use exponents, so I'll convert 1 over 32 to 2 to the negative 5 and 8 as 2 to the power 3 and 2 to the negative 1 for half, just like that. Then thereafter, I'm going to simplify the right-hand side. I'm going to distribute the power that you're seeing here, that negative, that n minus 1, and I'm going to multiply it by that negative 1 to get 2 to the negative 5 is equals to 2 to the 3 times 2 to the negative n plus 1. Then simplifying the right-hand side, I am going to get 2 to the negative 5 is equals to 2 to the negative n plus 4. Then once the bases are the same, as you can see, I'm going to do away with the bases whilst I immediately equate the exponents. I'm going to get negative 5 is equals to negative n plus 4. Therefore, my n value would be equal to 9. That means I'm dealing with 9 terms. But we haven't fully answered the question. We now want to find Sn. So I'm going to say our formula Sn is equals to A into 1 minus R to the power N over 1 minus R. But what do we know now? We've got our A, we've got our N, we've got our R. We just substitute those and we get 8 into 1 minus half to the power 9 over 1 minus half. Then using our calculator straight away, we get our S of 9 terms to be 511 over 32. Moving right ahead. How many terms of the series 5 plus 10 plus 20 plus up to must be added to give a sum of 1,275? The 1,275 represents your Sn, so you're going to state the values. Your A is 5, Your common ratio is 2. And your SN is 1,275. What are you looking for? You're looking for N. So we're going to use the SN formula for a geometric. So we're going to have SN is equals to A into 1, R to the power N minus 1 over R minus 1. Thereafter, we're going to have 1,275 is equals to 5 into 2 to the power N minus 1 over 2 minus 1. Then we're going to convert it into a linear equation into 1,275 is equals to 5 to the power 2n minus 1. Dividing both sides by 5, we're going to get 255 is equals to 2 to the power n minus 1. Moving the negative 1 across, it will become positive 256 is equals to 2 to the power n. Making sure that the bases are the same on both sides. One could opt to use logs here. I'm choosing exponents, so I'll get 2 to the power 8 is equals to 2 to the power n. Therefore, the bases are the same on both sides. That means I can immediately equate the exponents to get my n being equal to 8. That means I must add 8 terms to get that. So you can conclude to say 8 terms must be added to give a value of 1,275. I hope you enjoyed the lesson. Look out for the next lesson. Until I see you then, bye-bye.